diffraction grating or simply grating. So this term grating is new for all of us, right? So what is this grating? So, grating is an arrangement in which we are arranging n parallel slits, n slits parallel to each other, such that the width of the each slits are equal and also the space between each slits are also equal. If these are the slits, let this be A, B, C, D, I, J, etc. Now, this distance AB, if it is equal to A, if AB is equal to A, the distance CD will also be equal to A, and this EF, GX, IJ will all be equal to A. And if this distance BC is equal to B, or this space of this opaque space, or this width of this opaque space is equal to B, this DE will also be equal to B, FG and XI, J, etc. will also be equal to B. Okay. Now, this is the lens and this is the screen. And rays of lights will be coming through this and converging at a point if it is P. So such an arrangement is called grating. Now this grating was first constructed in 1882 by Rowland. And it is a very important apparatus in spectroscopy in the quantum mechanics and all. And now how can we construct this grating? For that you have to take a plain piece of mirror, and in that you have to start making parallel lines such that those lines are equidistant from each other. And the distance between, if this is our plain mirror and we are making parallel lines that are equidistant from each other on this plane mirror. Now, with what we are making this lines? With the diamond pointed pen, we are making this. We are making this parallel lines. Now, the distance between any two consecutive parallel lines will act as diffraction region or diffraction space. Diffracted region. In 1 inch there will be almost more than 500 lines of more than 1500 parallel lines drawn. Like that we can draw more than 1500 lines. In 1 inch means in 2.54 centimeter we are drawing this 1500 lines. So just imagine how small the distance between two lines will be. That much lines we are drawing, and more than such lines can be drawn. More than 1500 lines can be drawn, and such an arrangement will behave as n parallel slits. And this grating simply behaves as n parallel rectangular slits. Now we move to the actual theory part of the Fraunhofer diffraction at N-slits. For that, consider these are our N-slits. This is n is equal to 1, n is equal to 2, up to n is equal to n. Now consider that a parallel beam of monochromatic light is incident opaque space. Now we have grating element D, which is equal to sum of the width of this opaque space and width of this slit. Width of the slit is A plus width of this grating element, width of this opaque space will be B. So grating element is the sum of this A plus B. Now here this is the first slit. The center of the slit is same as O. Now just take this single slit. Here we are now considering the Fraunhofer diffraction at the single slit. This is the center of this single slit. Here we have a point B, and this distance from center of this point B is R. And here we have a small element dz. The distance of this small element dz from point B is rho, and this whole this distance is A. So this will be A by 2 each. This is P dash and this is P. Now we are finding the displacement at P dash. That displacement will be equal to K dz sin 2 pi into d by t minus rho by lambda, which is equal to K dz K sin by 2 pi into t by t minus r by lambda plus z sin theta by lambda. We are familiar with this equation, right? If we consider this K dz as amplitude A and this let this rho be x, A sin 2 pi t by t minus x by lambda. This is wave equation. So this K dz represents the amplitude, this small letter t represents the instantaneous time, and this capital letter T represents the time period, and this rho is simply the distance of the small element dz from the point P dash, and this lambda is the wavelength. Now on summing the effects of all the elements from one edge of the slit to another, for single slit we get dy is equal to K will be a constant and will be taken outside, minus A by 2 to A by 2 sin 2 pi into t by t minus r by lambda plus z sin theta by lambda into dz. Now we are taking sin 2 pi into t by t minus r by lambda plus z sin theta by lambda as phi of z. So this d by dt dy is equal to k into integral minus a by 2 to a by 2 to plus a by 2 for the first slit. For the second slit, the limits will be from d minus a by 2 to d plus a by 2. And for the third slit, the limits will be from 2d minus a by 2 to 2d plus a by 2. And for the nth slit, the limits will be from n minus 1 d minus a by 2 to n minus 1 d plus a by 2. Now we have to put all these limits in this equation and find the integration separately. I will be equal to a is a constant integral minus a by 2 to a by 2 phi of z dz plus integral d minus a by 2 to d plus a by 2 phi of z dz plus integral 2d minus a by 2 to 2d plus a by 2 phi of z dz plus etc. plus integral n minus 1 d minus a by 2 to n minus 1 d plus a by 2 phi of z dz. Now this phi of z is equal to sin 2 pi into t by t minus r by lambda plus z sin theta by lambda. So we have to put this value separately in each of these cases and find the integration. And on adding all those things and separating out the constants, we will get y is equal to k y is equal to k a sin alpha by alpha sin 2 pi into t by t minus r by lambda plus sin 2 pi into t by t minus r by lambda plus d sin theta by lambda plus 2d sin 2 pi t by t minus r by lambda plus 2d sin theta by lambda plus etc. plus for the nth slit it will be sin 2 pi into t by t minus r by lambda plus n minus 1 d sin theta by lambda. So just look at this case. In this we don't have the presence of grating element. Grating element t. In this case we have d sin theta by lambda, and this was the case of the first slit. This is the case of the second slit. In second slit we have d sin theta by lambda, and in the case of third slit we have 2d sin theta by lambda, and for the case in the case of nth slit we have n minus 1d sin theta by lambda. Now from the class taken by Ananda and Anila, we understood alpha is equal to pi a sin theta by lambda. So this is the this equation we got by simplifying the resultant amplitude, and we know that this summation P is equal to 0 to T is equal to N sin of x plus Pm is equal to sin x plus Nm by 2 into sin n plus 1 by 2 of m by sin m by 2. This equation learned like this and comparing this equation with y, we will get x is equal to 2 pi into t by t minus r by lambda and m is equal to 2 into pi d sin theta by lambda and this pi d sin theta by lambda is equal to beta. So m is equal to 2 into beta and n is equal to up to n-slits. Here n is equal to n minus 1. Sin alpha by alpha would be as it is. This 2 pi into t by t minus r by lambda is equal to x. So this term sin x will come. Sin x plus n minus 1 m by 2 sin n by 2. Now this how did this n came? N came by we are substituting this n minus 1 plus 1. In this equation we are substituting n as n minus 1. So n minus 1 is plus 1. They both will get cancelled and sin n by 2. This is equal to Ka sin alpha by alpha sin n by 2 by sin n by 2 into sin x plus n minus 1 into n by 2. So this total displacement y at p dash will be equal to Ka. This n by 2 is equal to beta. So Ka sin alpha by alpha sin n beta by sin beta sin 2 pi into t by t minus r by lambda plus n minus 1 d sin theta by 2 lambda. This is the total displacement at p dash. Now we find the intensity at p dash. So this intensity at p dash is equal to a square sin square alpha by alpha square into sin square n beta by sin square beta. Now this a square is equal to I0 sin square alpha by alpha square into sin square n beta by sin square beta. So this intensity will be maximum when this alpha will and beta when they both are equal to 0. So we will find the intensity of principal maximum. Intensity in the case of principal maximum. So then we have to consider that if sin beta equal to 0, beta will be equal to plus or minus n pi. This case was discussed by Anila, where n is equal to 0, 1, 2, etc. So then sin n beta will also be equal to 0. Now take these ratios sin n beta by sin beta. If you take these ratios, it will be of 0 by 0, 4. So we have to find the limits. So limit beta tending to plus or minus n pi sin n beta by sin beta will be limit beta tending to plus or minus n pi. Take the derivatives on numerator and denominator. D by d beta of sin n beta by d by d beta of sin beta. So it will be limit beta tending to plus or minus n pi. Derivative of sin n beta will be cos n beta, and we will be multiplying the n with cos n beta. Cos n beta into n divided by cos beta. Now take the limits inside. N cos n beta is n into plus or minus n pi divided by cos plus or minus n pi. So this will be getting cancelled. We have plus or minus n. So this value of sin n beta, sin n beta by sin beta, it will be plus or minus n pi. This ratio sin n beta by sin beta will be plus or minus n. Now the sin n beta by sin beta is equal to n. So the sin square n beta by sin square beta will be n square. So intensity will be I0 sin square alpha by alpha square into n square, or I will be equal to n square I0 sin square alpha by alpha square. Now we discuss the condition for principal maximum. We are taking this case slits. So pi into a plus b sin theta by lambda, which is equal to plus or minus n by these pi's will be getting cancelled and this lambda will go here. A plus b sin theta, which is equal to plus or minus n lambda, or d sin theta equal to plus or minus n lambda. Now this n represents this order of this interference maximum, and this, if n is equal to 0, it will be 0 order maximum, and n if n is equal to 1, it will be first order maximum. Like that, principal maximum will also come. And this plus or minus sign indicates that there will be two principal maxima between 0 order maximum. That is the case of minima. In the case of minima, the sin and beta will be equal to 0, but beta will not be equal to 0. So sin and these, taking these ratio sin and beta by sin beta, we have 0. And in the case of minima, the intensity will also be equal to 0. So for minima, sin n beta equal to 0, and n beta is equal to plus or minus m pi. This beta is equal to pi d lambda by pi d sin beta by lambda. And d is equal to a plus b sin beta by lambda, is equal to plus or minus m pi. Pi will cancel. So m into a plus b sin theta is equal to plus or minus m lambda. So this is the equation for intensity for minima, and this m can take any values except 0, except integral values. M can take all integral values except 0 and 2n, etc. up to nn. This is the graph. These are of same height. These two are of same height. This is the intensity. Here we get the central interest. Now this m equal to 0. M equal to 0 is principal maxima, and m equal to 1, 2, minus 1 is minima, and m equal to n also is principal maximum. I will just summarize all the equations that I discussed now. So this creating equation was a plus b sin theta, this is equal to n pi n lambda. This a plus b can also be written as b d. And this of these equations we solve one question. So the question is, a monochromatic light with a wavelength of 2.5 into 10 raised to minus 7 meter strikes a grating containing 10,000 slits per centimeter. Determine the angular positions of the second order bright light. Here it is given that the distance between the slits d is equal to 1 by 10,000. This is equal to 10 raised to minus 4 centimeter. This is equal to, converting the centimeter, we will get 10 raised to minus 6 meter. And the wavelength of the light is 2.5 into 10 raised to minus 7 meter. 2.5 into 10 raised to minus 7 meter. We are asked to determine the angular positions of the second order bright light. N is equal to 2. Okay. Now here we have d. This equation we can write as d sin theta by d sin theta is equal to n lambda. So we have n, lambda and d. With the help of these values, we can find sin theta. So this n lambda is equal to d sin theta. 2 into 2.5 into 10 raised to minus 7 is equal to d is equal to 10 raised to minus 6 meter sin theta. So this sin theta will be equal to 2 into 2.5 5 into 10 raised to minus 7 by 10 raised to minus 6 is equal to 5 into 10 raised to minus 7 is equal to 1 by 2. So sin theta is equal to 1 by 2. Theta will be inverse of